Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 6-4 on Special Parallelograms. This is the vocabulary and important ideas that you need to include on your notes that we're going to cover today. So to begin with, we want to go over what is a diagonal. A diagonal is a line segment that joins two non-adjacent vertices of a polygon. So they've given you one here, but there are several others. You could draw a diagonal here, you could draw a diagonal here, you can draw diagonals here. So anywhere that is non-adjacent and goes across the polygon is a diagonal. All right, today we're going to be focusing on the properties of diagonals in a rhombus. So there are two that we're going to cover today. The first says the diagonals of a rhombus are always perpendicular. So whenever we have a rhombus where all four sides are congruent, the diagonals in the center always cross at 90-degree angles. So not only is this one a 90-degree angle, so is this one, and that one. They are all 90-degree angles. And then our second property is that each diagonal of a rhombus bisects a pair of opposite angles. So what that means here is that this angle and this angle are the same as this angle and this angle because they bisect those. And the same holds true on the left and the right. It cuts that angle in half and this angle in half at the exact same measurement. And those are the two properties of diagonals in a rhombus. There's one property of a diagonal in a rectangle. And what that says is that the diagonals of a rectangle are always congruent. So DB from here to here will always be congruent to AC from here to here. What that means, you can also do the converse, you guys. So not only are the diagonals of a rhombus perpendicular and they bisect a pair of opposite angles, and for a rectangle, the diagonals are congruent. But the converse of those says if a diagonal of a parallelogram bisects the two angles, then that parallelogram is a rhombus. It also says if the diagonals of a parallelogram are perpendicular, then that parallelogram is a rhombus. Or if the diagonals of a parallelogram are congruent, then that parallelogram is a rectangle. So let's do a couple of the problems from your practice. So given this image here, they want to know what the most precise name is for the figure, and they also want to know what the measures for all the angles are. So because we have this right here, and we know that this is a parallelogram, that means that all of these angles are right angles here, which makes this a rectangle. And then there are many ways to find the different angles, but to begin with, because this and this is parallel, the top and the bottom are parallel, this angle here, the 18 degrees, and this angle here, angle 3, are alternate interior angles. So angle 3 is also 18 degrees. Because we know that in a rectangle, the diagonals bisect each other, that means that over here, this triangle is actually an isosceles triangle. So if this angle is 13 and this whole angle is 90, that means that the part that we don't know there is actually 90 minus 18, which is 72. And its base angle with 1 is exactly the same. So angle 1 is 72 degrees. In this yellow isosceles triangle, the base angles here are each 72. So if you add the two base angles together plus angle 2, it needs to equal 180 degrees. And what you get there is that angle 2 is 36 degrees. The only one that we have left is angle 4, and angle 2 and angle 4 make a straight line. So if angle 2 is 36 degrees, and they add up together to make 180 degrees, or a straight line, what you get is that angle 4 is 144 degrees. And there are all the answers to this problem. For our next question, they've given us a rhombus, and they want us to find the area and the measure of each numbered angle. Remember that rhombuses always have diagonals that are perpendicular. So angle 2 and angle 3 are both 90 degrees. Because a rhombus's diagonal also bisects opposite angles, we know that angle 1 and angle 4 are also congruent. And if we look at this triangle right here, we know two of the angles, 52 degrees and 90 degrees. So we can subtract from 180 to find angle 1, which is congruent to angle 4. So we've drawn the equation over here, and then we use our algebra to solve for angle 1. And what we get is that angle 1 and angle 4 are 38 degrees. So now we only have to worry about the area of a rhombus, which we can use by doing this simple formula here. So this part of the diagonal is 10, which means this part of the diagonal is also 10. So the area is 1/2 of 20, 10 plus 10. And then for the other diagonal, this part is 13 and this part is 13. So the other diagonal is 26. We'll multiply those together and divide it by 2. Or multiply it by 1/2, which is the same thing. And what you get is that the area is 260. Our next question says that the parallelogram is not drawn to scale. Can the parallelogram have the conditions marked? If yes or impossible, it's best and the best explanation to go with the choice. So what we see here that's been marked for us is that this angle is congruent to this angle, which in turn would be congruent here and here, showing that this diagonal has bisected that opposite angle. So the answer is yes, this parallelogram is a rhombus. And our last one for the day gives us a rectangle HIJK, and they want us to find what x equals. So if we were to draw this, we have a yellow diagonal and a red diagonal, which would have to be equal to each other. So HJ and IK would have to be equal to each other, and we can set our equation up just like that. And then we can use our algebra to solve for x. So in this case, x would equal 6. And then we have to take that x equals 6, and we have to plug it back in to see how long the diagonals are. And because the diagonals are congruent, it doesn't matter which one you choose. I went ahead and picked the red diagonal, but you could have chosen the orange diagonal as well. I plugged in the 6 for x, and I did a little bit of math, and what I found out is that the diagonal, it measures 25 units each. Good luck, everybody. I hope you guys all do great.